Hello students, welcome to the iRobot Automation YouTube channel. In this video, I'm going to demonstrate the batch process, that is PLC ladder logic development for batch process. That is as per the syllabus of EEE pathway. Okay. So it is of 20 marks question. So I'm discussing for the theory exam paper. Okay. For 20 marks, they're asking process algorithm or step-by-step procedure or instruction, that is part A, and block diagram of the system and PLC ladder diagram, and selection of proper sensor, motors and switches. This will be common, that is I will explain in the class. Okay, but three parts of the question I'm going to explain, means I'm going to give solution for this. Okay, you need to practice in the lab with the PLC kit. Okay, and this is a theory paper question, and so to make you understand better, I'm using HMI, but HMI screen is not the part of the question. Okay, so don't waste time in writing HMI screen and all. That is only for understanding purpose. So you have to write only 3 steps. Okay, and selection of sensors and motors are there. That is extra things, but major part is only 3 parts of the question. Okay, so let us discuss about the process algorithm. Before that, we need to understand what do you mean by batch process. So this is a problem statement I have taken. So in the examination only theory paper, theory paper, there is only a question this much, descriptive question. This one is a descriptive question, no schematic diagram, nothing. You need to assume schematic diagram, but to avoid the confusion, let us stick on to the one schematic diagram, that is batch process. You got my point? In this question there is no block diagram, no information, so you need to assume everything and then write the process algorithm, block diagram, schematic diagram, that is PLC ladder diagram. Okay, fine. So for that we are assuming this is the schematic or the diagram for the batch process. Okay, batch process means liquid A will fill first and liquid B. So since there are 2 liquids are there, so we call it as a batch by batch or batch production. Okay, this is used in chemical industry. Fine. So we need to understand the problem here. So there is a 2 ingredient are there, or chemical is there. For example, say ingredient A is start filling to the tank by opening solenoid A. So there is a solenoid A and solenoid B to fill the ingredient B. Okay, and there is a start button is there, stop button is there, and there is a steering motor for proper mixing of ingredient A and ingredient B. There is a steering motor is there, and once it is steering is completed, that means that liquid means it mixed properly, and then that is a final liquid. Okay, so that is filled in the finished tank. Okay, so by opening a solenoid C, so finished fluid will fill into the finished tank. Okay, but there is also one low level sensor is there to sense the low level condition of the tank. Okay, so altogether there is a start button, stop button and low level switch. So 3 inputs are there and 4 outputs are there, solenoid A, solenoid B, steering motor, solenoid C. Okay, so this is a required operation. First solenoid A will on and start filling ingredient A, okay, for 200 seconds. Next, after ingredient A in the tank, ingredient B start filling. That means by opening solenoid C, ingredient B will start filling, that is for 200 seconds, that is T2. Once solenoid A, solenoid B, that means one ingredient A and B both are completed, the next that is steering motor is going to on for 100 seconds. After the mixing is completed, solenoid C should open the solenoid C will open so that it starts filling the finished tank. Okay, but Solenoid C will goes off when low level limit switch is on, or low level sensor gives a signal, then solenoid C should automatically close, that is off. Okay, so this is a required sequence. This is a problem statement we are assuming to demonstrate the batch process using PLC. I hope everyone understood. Okay, so for this, now the part A question. Part A question is write the process algorithm step by step procedure or instruction. So this you need to write for this question. Step 1 is when power is on, means initial condition. See, initial condition, all solenoids A, B, C and steering motor should be off, and wait for the start button to be pressed. If stop button is pressed, all operations should stop immediately. Correct. Step 2 is start filling process, means by operating start button, solenoid A will be on. Allow liquid A to fill the mixing tank and keep the valve open for specified duration time, that is T1, to ensure correct quantity. That means T1 time is, according to the problem definition, is 200 seconds. Then after T1, close valve A. Step 3 is solenoid B will be on, so allowing the liquid B, that is ingredient B, to fill the mixing tank and keep the valve B open for time duration of T2, that is also 200 seconds. And then after T2, close valve B. Mixing process, once liquid A and liquid B both are in the tank, so start the steering motor, run the steering motor for the period of T3 time, that T3 time is nothing but 100 seconds. And after that, stop the steering motor, drain to the finishing tank. That means once mixing of fluid A and B is completed, then we should open the valve, that is C, to discharge the mixed fluid into the finisher tank. Then keep the valve C open until low level sensor or switch detects the tank is empty. Okay, so once tank is empty, close the valve C. And emergency stop handling means when stop button is operated at any time, immediately you have to switch off all the valves, that is output, valve A, valve B, valve C and steering motor. And next operation will start only by operating start button. Okay, so this is the step-by-step procedure you have to do it. That is question number A. This is a summary actually. This matrix is optional for you. You don't have to write, but for your understanding purpose, it is given here. Okay, start button is there. Then valve A is on. So T1 is a fill time. Once T1 is done, we are going to switch on valve B. Okay, so this is a summary of what we discussed now. So this is a block diagram. There is question number 2, that is a part of the batch process. So here start button, stop button, both are inputs to the PLC, and there is a limit switch is there, low level sensor is there, that is also input to the PLC. PLC output is nothing but solenoid A, solenoid B, steering motor, solenoid C, and these will going to control the mixing of the mixing in the tank, right? So finally after mixing, liquid is going to the finisher tank. So there is a feedback from the mixing tank, that is low level sensor, and once that feedback we got it, that is we are sending to the PLC. So this is a complete block diagram. So this is the question number 2, that is part of batch process. And next is we need to develop the ladder logic. So ladder logic development, first we need to list the input and output. So there are 3 inputs are there and 4 outputs are there. Start, stop and low level sensor. Output is solenoid A, solenoid B, solenoid C and steering motor. But since we are in Delta PLC, inputs are labeled by X0, X1, X2, and output is denoted by Y0, Y1, Y2, Y3. So there are 3 inputs and 4 outputs in this problem statement. That is IO addressing is the first step. And before writing, see, for each and every problem, you cannot remember or memorize the ladder logic. So for that, you should have output state matrix. So using output state matrix, you can easily write the program. Okay. So what I'll do is, when start button is operated, I'm going to store that signal in the memory bit, that is M0, and whenever stop button is pressed, then memory bit will be off. Okay, this is a memory bit. But next is solenoid A. So solenoid A, when it should be on, so the moment you operate start button, that is memory bit M0 is on, I'm going to switch on solenoid A. So when solenoid A should be off, after T1, when T1 is completed, when T1 is on, then solenoid A should be off. And also whenever you press stop button, solenoid A should be off. So that is the second instruction. For switching on, only one instruction. For switching off, two instruction is there. So like this, solenoid B, solenoid C and steering motor conditions are given. So based upon this output state matrix, I can easily draw the ladder logic. So it is given here. So this is the storage of start signal in the memory bit M0 using latching function, and this is for solenoid A, when to set and when to reset. That is what I'm following the method. That is easy, and you can easily reproduce ladder diagram in the examination. This is the first two lines. Okay, this is after T1, solenoid A should be off. That means after 200 seconds, solenoid A should be on. So that is why I'm given the reset instruction. Once T1 is on, I need to switch on solenoid B so that liquid B will enter into the tank for the period of 200 seconds. Once T2 is on, I'm going to reset solenoid B, and I'm going to initiate steering motor. See, this is reset, this is set. Once T3 is completed, I'm going to switch off steering motor, that is 10 seconds, sorry, 100 seconds. And solenoid, once T3 is on, solenoid C is going to on. Solenoid C should be off, should be reset only when there is a low level sensor is off. And when stop button is pressed, then also solenoid C should be off. Okay, so this is what the ladder diagram. So whenever this question is asked for 20 marks, you have to write part A, that is process algorithm. Process algorithm you have to write. Then block diagram you have to write. Then ladder logic you have to write. Ladder logic you can directly write, but if you write the input IO addressing, it will be very clearly understandable to the evaluator. Okay, so IO addressing, then output state matrix. With these two, means actually output state matrix is drawn based upon the schematic diagram. Okay, so that means you don't have to remember or memorize the ladder diagram. You can draw the output state matrix using the schematic diagram. From this output state matrix, you can easily write the ladder logic. Okay, so only three parts are there. So this is for your question. And there is another part is there, selection of sensor and motor. That is common for every application, so that I will give you in separate section. Okay, so thank you everyone for okay, there is one I will show demonstration now. Before completing the video, there is a demonstration. That means PLC logic is already ready. So I am going to open the ComGR and start the simulation. Right now I am working on simulation because I don't have, right now there is no PLC kit. So download the program to the virtual PLC. Go online. Make sure that PLC is in run mode. Okay, don't check the output when it is in stop mode. So go to run, then put it in the run mode. Now it is in run mode. Now I have designed HMI screen also. So go to project, offline simulation. See, HMI screen is not the part of the question. Okay, so for your understanding purpose, I have taken the HMI screen here. Okay, and I've taken here T1 means the display also I've taken how much time is completed to show that. T1 display I've taken, T2 display I've taken, T3 displays T3 display I've taken because timer 1 for solenoid A, timer 2 for solenoid B, timer 3 for steering motor. For solenoid C there is no timer, but input is low level sensor. If low level sensor is off, then solenoid C should be closed. Okay, and there's a start button is there, stop button is there. So since I've taken X and X1 for start and stop, I need to operate from PLC only. So I am forcing on start button. You can observe here T1 timer starts. For 200 seconds it is counting. Okay. Now steering motor is running, and also we should enable the low level sensor initially, because when solenoid A is on, the moment solenoid A is on starts filling, right? So you should initially switch on the low level sensor, because low level sensor is not off, because some amount of fluid A is there, so immediately low level sensor will be on. Okay, so now the level sensor is on means there is some amount of liquid is there in the tank. So that is why solenoid C is on to drain out the liquid which is present in the tank. But now once tank is completely empty, you should manually enable the sensor so that solenoid C is closed, so that it's completely drained out the liquid present in the tank. So finished tank is filled with the final liquid, that is combination of liquid A and liquid B. And the moment if you press, say for example, I am going to say for example, this is one more cycle, I'm going to, so now again one more cycle is started, but during the process if I press the stop button, see, everything is stopped. That is required in the as per the question. So this is how the ladder logic development is done, and the HMI screen taking help to make you understand this complete process. Okay. Thank you everyone for watching this.